Hey everyone, so in this video we are going to look at a character controller for when you can only choose what direction your character moves in. You can't choose how far they travel. Games that have used this in recent days were Slay Away Camp, as well as Killer Puzzle. I'm sure there's other ones I haven't thought of. So if I press up, my character travels all the way up. If I press down, my character travels all the way down, and I can't interrupt the movement. That's the whole idea, is you're using the perimeter of the room as well as obstacles to control where your character is going. So if I move there and then I move up, he auto attacks and the enemy is defeated. Now I wanted to demonstrate this because even though I did the 2D version yesterday, there are some substantial differences in this one, not to mention I didn't handle the animation, so I figured I'd do that as well. So first, the basics. Uh, Obviously, main camera is a default object when you create a new scene. Directional light is the default object when you create a new scene. These were just created from game object, and then it's either 3D object cube or the plane. Nothing special about them. I just scaled them out. Okay. So, as I mentioned in the 2D video, the way that this works is your character is moving consistently and aligned with a grid. So we want to be able to control on a one-by-one basis his position. So like for instance, he should only be occupying a space no greater than 1 by 1 by 1. Technically, you don't care about the third dimension vertically, but just to be accurate, it is a cube. Likewise, the cube should not be any more than 1 by 1 by 1. And as fate should have it, when you create a cube using Unity, it is exactly 1 by 1 by 1, which makes a lot of sense. So cubes are great if you're trying to use a grid because you can really easily mark out how much space is being used by that 1 by 1 by 1 limitation. Okay, so any obstacles. Now, can you have an obstacle that's bigger than 1 by 1? Yes, but it would have to be bigger by an increment of 1 by 1. So like for instance, I could put a second block here, and it would have to be, that's the z-axis, exactly 1 over. So it has to be aligned on the x, which is 0. So this one would be 0. And it was moved up exactly 1. Can you do diagonals? You certainly can. So if this was, say, -1, but again, it's an increment of 1. So that's the thing to keep in mind. It's very important that everything is predicated upon that grid, that nothing takes up more than the space of 1 by 1 by 1 or an increment of 1 by 1 by 1. Okay, so that's just the default stuff that you can build. Now these are the more proprietary stuff. I bought these from the Unity store. You can use whatever you want. I'm currently using this in my first game that I'm working on, so I figured I'd just repurpose them for here. I just want to call out one thing, that these models already have animations built into them. So if you click on the animator tab, you'll already see all those animations. I didn't have to do any of this. If you purchase a character and it's animated, if that animator did it right, if that the person who created the package did it right, those animations should already be attached, embedded to the character. You shouldn't have to do anything. They should already be there. So I didn't have to do anything special here. You didn't miss anything. When you download when you download the assets, those should already be there. Okay, so what we're going to do now, we're going to look at what I added to it. So it already comes with a transform, so it can have position, rotation, scale, that kind of thing. It already comes with an animator, as I said. Now I removed the capsule collider. The reason for that is because, again, we want to try to keep it within this square grid. So I got rid of the capsule collider and I added a box collider. And just like in the 2D, we'll click on our bool. I clicked on edit and I try to get this as close to 1 by 1 by 1 as I could. Again, if you're going to err on the side of being slightly too small. If you make it slightly too big, you might accidentally clip something as you're passing it, and then your character stops where they shouldn't. So err on the side of being slightly too small. So the Minotaur has a box collider, has a rigid body. Again, that I had to add, and again, you just add these by clicking on Add Component and then choosing the category. In this case, they're both physics, and then you choose Box Collider, and then you choose Rigid Body. Only thing I did with the rigid body is I shut off gravity. That's it. So everything else by default is fine. Okay, so for the Cyclops, I didn't add a rigid body because he's not going to move. I just, again, removed the capsule collider and added the box collider. He gets his own script, which has like maybe 2 lines of code in it. We'll get to that in a few minutes. Okay, so our Minotaur. So we reviewed what components I removed, what components I added, and now let's look at the script. So the bull script. So nothing in the start section. We do create a variable that's going to be used to check if your character is moving. Why? Because as we said, you can't interrupt the movement. Once you choose a direction, you're committed until you collide with an obstacle. This is the same section of code repurposed 4 times. So if there's input, what kind of input? A key being pressed down, which means it's true for just 1 frame, the first frame that it's pressed. And what key press are we looking for? W. That's it. We're just saying if a W is pressed down. When the W is pressed down, what do? This is different. This we did not do for the 2D. So in the 2D, you have a character that's basically just facing up. So I didn't bother with the Euler angles. In this, your character very clearly is facing in a certain direction. So unless you want them to be like, strafing side by side or walking backwards, if you don't want any of that, then you need to change what direction they're rotated in. So get component transform.Euler angles equals new vector 3, 0, 0, 0. So again, if you click on him, here's his rotation, 0, 0, 0. Okay, so that's the first thing that we really didn't have to do in the last one. We didn't handle rotation. Second thing, we're not going to say, we're not going to use a constant on a specific axis. Like in the 2D version, we said move a certain velocity along X, move a certain velocity along Y. We don't do that. We just say move forward. So we already have the character facing a certain direction. Now we're saying move in that direction. So by having this built-in function forward, then you don't have to calculate that yourself. So get component, rigid body, velocity, and again, you're not saying a constant, you're saying transform.forward times 5. So whatever direction this character is facing, move them at a base velocity times 5. This is arbitrary. You can make this whatever number you want. And again, like I said, for games like this, it tends to be quicker. So you rotate them, and then you move them in that direction, and then you set this to is moving, because what we're going to do is we'll add an extra condition up here that checks to see if he's moving. But I didn't want that at first. I didn't want that to get in the way. And now it's just rinse and repeat. If you press S, you're going to rotate 180 degrees, because that just makes sense. If you're facing one direction, you turn around the opposite direction, that's 180 degrees. And again, you're moving forward, transform.forward times 5. So this line of code is really repeated 4 times. So there's probably a more concise way of doing this, but again, I like to make things be as clear as possible when I'm doing the teaching. I'm not worried about optimizing of code. Rinse and repeat. If you press the A key, rotate 90 degrees. Again, that makes sense. If you're facing one direction and you turn left or right, you've turned 90 degrees. And again, transform.forward times 5. And then the final one, get key down, D, rotating the opposite direction, and again, transform forward. So if you want, I'll just do this. So if you want to pause the video to type it out, again, people have asked me to not type out during the tutorials because they said it takes too long. I will type out a little bit, but not yet. And then this is just checking for a collision, because again, if we had left this as not a trigger, then collisions would automatically stop. Okay. The problem is we need your character to be at the right position. And from what I've seen, if you use the built-in collision, there looks to be a little bit more of a bounce. So I'm trying to minimize the bounce. So It also gives us greater control to be able to lock things out if we're checking for that. So void on trigger enter, collider other, that will automatically show up when you type in on trigger enter. So what are we going to do? Well, if you watched yesterday's, it's very similar. We're going to say no more velocity. So get component rigid body dot velocity equals 0, 0, 0. So this should be identical. In this case, we don't have to say forward, back, left, right because it's 0. So we're just saying stop moving. Get component transform dot position. This is the same ugly statement that we looked at yesterday. So I'll just give a briefer explanation this time. So this is X, this is Y. Again, you're not moving vertically, so you don't have to change that. And then this is Z. What we're doing, we're saying what is the current X position, round it to the nearest integer. So since you round to the nearest, then you don't have to worry about your character jumping forward or back. They're just going to adjust again because we want them to be in the center of one square of that grid. So mathf dot round to integer. What are we rounding to the integer? The current position of x. So in other words, take the current x, round it, and apply it back to the x position. And then just rinse and repeat for z, and make sure you have 0 in there for y, because again, he's at the y position. 0 y position, excuse me. And then this is where is movement will be set back to no. And then we check. If the name of the other object is Cyclops, see, the name of the object is Cyclops. So if the other dot name is Cyclops, and if you haven't seen this before, make sure you're using a double equal sign when you do an equal. Get component animator dot play attack 01, and it's really that simple. So if we go back to the Minotaur, go back to the animator, zoom in, attack all one. It's that easy. You can just call it. Now, can you do things like you can right click and choose a transition and do it that way? I try to avoid that kind of, I don't want to call it spaghetti code, but you start getting all these lines pointing in different directions, and that is legitimate. You can do it that way. But again, I believe in clarity. So for this tutorial, I think it's, and it works for a simple program like this. So if you're colliding with Cyclops, then play the attack. So all that's really left is to look at the Cyclops to see how he responds. So actually, I don't even have to move. I can just click here. So as we said, the enemy script is attached to the Cyclops. So what we do is we say on trigger enter, and unless something is going wrong, the only thing that should ever collide with him is the bull. So we're not checking for a name. So as with the bull, we can collide with all kinds of objects because we're moving. Since the enemy doesn't move, he shouldn't collide with anything. So that's the only reason why I'm not checking to see if it's the bull he's colliding with. So if there's a trigger collision, what do we want to happen? We want to run this coroutine. That's this. Yield return new, wait for seconds, 0.6f. So why 0.6f? Because that's roughly how long it takes for him to swing his axe. So we don't want the Cyclops to go into its death animation until the axe has been swung. So I just eyeballed it. I said, okay, this looks about right. So wait for 6 seconds after the collision and then go into the die animation. So sure enough, this should look just like what you saw on the bull. Get component, animator.play, and then the name of the animation. I'm not going to go back to the animator. You can check that if you want. Well, you can't check it unless you have the asset, but it's there. And then destroy game object 2. So this is similar to this in that this is the delay to let the axe animation play. This is the delay to let the die animation play, and the die takes, it doesn't quite take 2 seconds, but you want to see him on the ground and then he disappears. So destroy the game object after a 2-second delay. And that's it. There's really nothing else to say. I hope that you found this useful. And I think that's about it. So it's basically the same topic 2 days in a row. I typically don't do this, but again, like I said, for the 3D, there are several things to consider. Like we said, the rotation of the object, as well as playing the animation. But I think that should about do it. If you found this interesting, please do a like, please do a comment if there's anything that you would like to see, and please enjoy the rest of your day.